Hey folks, this video is a continuation of my intermediate Python series, but the next several are going to be kind of standalone. So the idea behind the whole series is that you don't learn how to program just from watching me program, right? You learn to program from programming on your own. And this is designed to give you a project to work on, because you're going to learn so many different things doing all the things that happen in this big project of making a Dropbox clone. But the next several videos are going to be specifically about WebSockets. I want people to be able to come in on these videos if they're just interested in WebSockets and don't care about the rest of this. So this is a great module, WebSockets. It's on pip. It's great for asynchronous networking stuff, but it isn't particularly well documented. Like there aren't a lot of people showing you the best practices for this. So I've spent the last month and a half like really testing this thing out, trying to figure out good ways of structuring stuff. And I've got it. Like I really feel like I've nailed it. So I'm hoping that this is going to be really helpful to anybody who just happens to come along this video and sees, hey, this is how you WebSockets. I don't ask people to like and subscribe and all this stuff, but I am going to ask you to share. I'm working so goddamn hard on these videos, and it's not finding an audience. Like, if you think that this is of value, please let other people who might be interested in this know about this. Because, man, it's a little heartbreaking to see some of these videos getting less than 100 views after all the effort I'm putting into these. So let's get on with this. This is the best way to use WebSockets. To start this off, let's make a networking file that we're going to put all our networking stuff into. And we're going to import the socket module, which is built into Python, so we don't need to like pip install it or anything like that. But we do need to figure out what is the IP of the machine that's running our code. Like before we can do any kind of networking stuff, we got to figure this out. And if you were to ask Google, Google's going to give you the wrong answer. So Google will tell you that you go socket get host name to get the host name. So this will be whatever you've named your computer. And then your IP is supposed to be socket get host by host name, and then we would plug in whatever our host name is, and this should be our IP. And that does look like a reasonable IP, but that is not my IP. So if I go to my terminal here and do an ipconfig, we do find that IP, but this isn't the actual IP that I use. This is only used if I'm using a virtual box, a virtual machine. So this will work in like 90% of the time, but if you've got a complex, like multiple Ethernet connections on a single machine, it's not always going to give you the right one. Now, fortunately, the socket module can still get us the right IP, but to get the right IP, we need to make the computer establish a connection to the internet, and we'll figure out which of the many possible Ethernet connections it's using to connect specifically to the internet. So to do that, we're going to use a with context thing here. We're going to create a socket from the socket module. And now it is expecting us to tell us what type of connection we're trying to make here. So we want to make a IPv4 connection because we're interested, like this is an IPv4 address, this is IPv6. We're specifically interested in IPv4, so we do that by giving it this socket AFINET, and then you need to tell it what type of protocol it should be using. So you've probably heard of TCP over IP. There's also UDP. That's what we're going to use, and that is a sock datagram. So it's sock underscore dgram here. So we're making this socket, and we're calling that socket S. And now we just need to make that connect anywhere on the internet. And this needs to be given as a tuple because we're going to give it the IP and the port. And the easiest one to remember is Google's DNS, which is 8.8.8.8, and then 53. And note here that 53 is being given as an integer, and the IP is being given as a string. So once it makes that connection, we can just do get sock name, and that's going to be returning a tuple. So we'll overwrite what we have for my IP as the first part of what this returns. Here, I'll just show you what this returns. So we want the first part of that to be my IP. So now we got our actual IP. Print it here just to show you. So this is the lie, this is the truth. So you can do all the server client connection stuff with the socket module, but that's not going to be useful for us because we need our thing to be asynchronous, and socket is not asynchronous at all. Like, it's going to break our UI, it's going to break all our background processes every time it's trying to do anything. So that's not good. We need to be using an entirely asynchronous module for all of our networking socket handling. So instead of using socket, we're going to import either through pip install, or I'm going to use the package manager here in PyCharm, Websockets. Make sure that you've got the S at the end of this, because there's also a WebSocket module here on the pip. So you want specifically the sockets. All right. So we install that. And let's import that. We're also going to need async IO. And while I'm thinking about it, I'm going to import traceback because we're going to be using this for some error reporting stuff later. So what we've got right now is good. We want to always be finding the host name and the IP for the machine that we're, let's get rid of this part because we know that that's the wrong part. So we always want to find the host name and the IP of the machine that's running our code. So whenever this module is imported into our main project, that's fine. It should just do these things outside of any kind of function or anything like that. But if we're starting a server, we don't necessarily want that to always start whenever we import the networking document, because that could be a mess. So let's do a main clause here. So only if the name of the thing that is running is this, which is the way that we describe it. If networking is the thing that we're running, then we want to be starting a server. So let's make a start server object from the WebSockets serve. And here, it wants a whole bunch of stuff. We don't have to give it all this. The first thing it wants is a WebSocket handler. We're going to build that in a second here. We'll just say that we're going to make a thing that's called register client. And then we need to give it the host, actually the IP. So we'll give it my IP, and then we need to give it a port. There's a lot of tricky nuance to picking a port for your program, because there's a lot of different programs out there that are already using up a lot of different ports. So you need to find one that's not going to be used up by anything else. For the purposes of this, I'm going to use 1111 because it's easy to remember, and I know for a fact that there is no major program that uses that anywhere. So we'll use that. So now we've created a start server object, and we can just stuff this into our event loop. So we do async IO get event loop, run until complete. We give it this start server thing, and that's it. That does it. So also get the event loop and now run forever, because we're going to be throwing other things into the event loop. But just doing this starts the server. We need to now make a function called register client, so that when somebody connects to us, it's going to know what to do with it. So let's define this register client. And when a client does connect, this server thing is going to pass to our handler the WebSocket itself and a path, which, like, if you go to a website, you got /index or whatever. That's the path. That's not going to be relevant to us at all, because we're not going to be using paths. So we do have to have a second argument in our function, because if we're only looking for the WebSocket, it's going to break when it tries to throw 2 at us. So we can just put an underscore here, and that's going to basically null it out. But you definitely have to have something right there, or else it's going to break, because it's going to pass the path even if there is no path. So this function is where we're going to stuff all of the things that we want our server to do once it gets a new client connected to it. A good example of that, it would be to wait for it to say something. So async for message in WebSocket, print message. Now, you'll see that it's still got a red underline here, and usually that means that I don't have a a function that I'm calling here. But in this case, it's actually a type error, or it thinks it's a type error, where it's looking for an awaitable object and instead it's getting a coroutine. And if you come across this in anything, it's something you can completely ignore. As long as you're running like Python 3.7-ish or later, you could probably ignore this, because that awaitable and coroutine are just different versions of the same thing that are they're confusing the linter inside of PyCharm. Like that's all that is right now, is PyCharm being confused about this. So it's looking for the same thing. We've got it. We got a server here. All right. Like if I run this now, we shouldn't get any errors. It's not doing anything because we haven't made a client to connect to it, but this is creating a server. So let's make a client so we can actually see that. Now, to make the client part here, though, we're going to have to really think about what we're trying to accomplish here. So I've got a helpful little animation to walk us through that whole process. So it's easy to make a connection to a known fixed server, because you can just use whatever IP or host name that is, like when you're connecting to a website or whatever. But we're going to try to connect to unknown IPs. And to do that, we're going to need a port scanner, where we're going to just run around through our local network trying to find anything that's going to connect to whatever port we've specified as the port of our app. So it's going to keep trying to connect to every single possible IP in our local IP range. And if it connects, great. If not, it moves on to the next one and tries the next. So let's make a async port scanner. And the first thing we need to do, this is for real, we need to make sure that we're only on a local IP when we're doing this, because in a lot of jurisdictions, port scanning is illegal. So you don't want to be out on the internet port scanning all over the place. Like that would be bad. Your ISP would really not like that. So let's make sure, like damn sure, that we are on a private network here. So if not, we'll take the my IP here and get the last three of whatever that is. So if this does not equal 192 and not my IP. Yeah, I'm doing this right. Okay. I'll explain it in a second here. I got to remember all the possible local private networks. Make sure I'm nodding at all of these. Okay, so we're just getting the last three of our IP, excuse me, the first three. This is :3. Here, let me show you. My IP equals 1. And my IP, the first three. Okay, that's what we're doing here. We want to make sure that's either 192 or 10 dot or 172. And if it's not one of these, then it's going to fail this and condition. So we want to print that, let the user know this is not a private network. Shutting down. And we'll just exit. And in fact, I'm going to strongly suggest that you double check that you got this part right. So let's just stop what we're doing. We're going to make a little client tester thing to make sure that we're doing this right. So, because like seriously, you don't want to screw around with it. So here we're going to import Dropbox networking and async IO. And we're going to create a client things function that's just going to do whatever it is that we're testing here. So we're testing the networking port scanner, and we need to await that. And to run this now, because this is an async thing, we can't just like call this anywhere else. That's just not gonna work. We need to actually stuff this into an event loop. So let's do that, do the main clause here just to be neat. Async IO, get event loop, run until complete, client things. And all right. And this should work. All right. It didn't crash out, so that was correct. But let's just make sure that it does close itself if it's not if we're not on one of these known private networks. So I've just changed this to something that isn't. Okay, so this is not a private network, and it did shut down. Okay, yeah, everything's working. Great. Let me put that back to 192 so that works correctly. So we need to figure out what is the range of IPs that we are going to be trying to connect to. So we know what our IP is, and we can do that. I haven't shown you guys any kind of neat tricks with lists, and we're going to be doing a really neat trick with lists here. So let's say that our IP range equals, and we take our IP and we, because our IP is a string, we can split it on the periods. And I'll show you what we get here. So now we get a list of these 4 strings. You notice that even though they're numbers, there are strings here because they're inside of these quotes. So we can now do our pop trick. You might remember we did that previously, where we can just pop out this last one because that's not going to be relevant. We're looking for, oh, oops, I should probably print that we did that. See, we're popping out this last one because that's what we want to get rid of. We want to be able to put in our own numbers here. And now we're going to, let me clean this up so you can follow it a little bit easier. Now we're going to do a join. We're going to join this list. So to do this, we make the character or whatever we want to be the connecting tissue between our list elements. So in this case, we want it to be a period because we want it to look like an IP. And so once we make this little string that's just the character we want everything to join around, we can do a join and we stuff in the IP range. And now the IP range is this right here, like that worked. So now we've got a new string that we've created from our list that we created from our old string, and it's exactly what we need here. We got the basic. I was taught that this was a C class. That's not correct, but like this we're up to this part where we can stuff in things after that. So now that we got our range, we can just say, okay, let's ping every single possible IP in that range. So I equals 0 while I is less than 255 here, because we're going to increment it inside of the loop. So I is now going to be 1 to 255. We're going to look for a target IP, which I'll just use an F string here to put everything together. We're going to use our IP range, then a period, and then whatever I is. And let's print that to make sure we're doing this correctly. Great, yeah. We got all the possible IPs in this range. Now we want to actually attempt a connection to all these. So I'll say our connection is equal to await Websockets connect. I should make this a URI because it'll look neater. URI equals, and we're going to do another string here, WS / target IP colon, and this is going to be whatever our port is. So we're using 11111. So this is the place we want to connect to. We just plug that into here. And then we want to test the connection by sending a message like hello. Now that needs to be awaited too. Now we need to get into all of the possible error handling because we're going to immediately start hitting errors. So let's stuff this into a try and start accepting the exceptions that we're expecting. So a big one is just be connection refused. We'll just pass on that, or we should just pass on that, but I want it to be visual for you guys, so we'll just say no server or server connection refused. And there's also going to be I'll hit the other errors as we. There's also a closed that we should probably yeah, let's just get this general one passed here. Everything else, though, we want to see what that is. So we're going to use traceback's print exec, which gives us a traceback exactly like if we had hit an exception that we weren't handling for. And that'll be very informative. It'll give us the details of what type of exception we're hitting, and we'll be able to handle for that. So this is going to immediately kind of hit that connection refused and connection refused. But here it's timing out because it's trying to wait a really long time for this connection. And there is a timeout argument inside of WebSockets for this connect method, but it completely ignores it. And it's maddening. So yeah, you see here, we did get this timeout error, and that wasn't handled for, but we've got that in our traceback exception here. So, and you'll see that it did move on to the next one, which is also going to timeout. But there is a way to make this work that's just a little odd. We can use async IO's wait for and just stuff what we want it to wait for in there, and we give this a timeout of since we're doing a video here, I'll give it 2 seconds, and this is going to create a different type of error, but we can handle for this accept timeout, and now this timeout error is not a built-in sort of thing like these connection errors were. We need to actually import this exception in order to handle for this exception. So let's do that from concurrent futures import timeout error. I'm going to import this as connection timeout error just so it looks nice and neat with the rest of our exceptions here. So accept connection timeout error. Let's actually make this a F string here. Timeout on, and we'll say the target IP. Oh shit, I guess my timeout length was too short because it's not getting the refuses. Because there are actual machines there where it's refusing, and I want to be catching those refuses. Okay, so yeah, that's giving it enough time to connect, but still moving on rapidly. So there we got a timeout, and another timeout. And so yeah, okay, that's working. Let's now actually make sure that this will work. Let's cheat real quick here and skip this up to 140. Because remember, in our server handler for clients, it should print out the message if we now run the server and the client together. So here's the server going, and now let me get the client going. So it's starting at 141, which is going to time out. Timeout. Okay, so no timeout. That worked. So let's check our server, and it did. It got our message. So here is where we could try to start writing some logic for like async for message in connection. Print message. So now let's make this just reply So await message send, or WebSocket send hello yourself. And this should work. Let's restart the server. Let's restart the client. And we got our message back. So we're getting the message on the server and we're getting the message on the client. And this is, like I said, this is where you would put the actual like program logic of what you want to do with this client and what you want to do with this server connection. But you'll notice that our port scanner has stopped. It's just stuck right here on this async for message in connection. It is not going to move from that at all ever again until the connection closes. Like actually, if I do this, it's going to create a connection closed error, which I wasn't handling for. Oh, that's in WebSockets. WebSockets exceptions. Connection closed. There's a bunch of different connection closed types. There's error and OK. The closed is the super class, so we can just use that. That's what happens when the server closes things. And then it moved on from there and it started trying to connect to other IPs in its range. But that's a problem for us because we're trying to create a peer-to-peer network and we want all of our connections to be connecting, like all of our programs to be connecting all over the place. So we can't have it just give up after it connects to one. So that's what we're going to do in the next video. We're going to structure this in a clean, useful manner for peer-to-peer connections instead of this simple server-client relationship. God, I hope that this was something you could follow. Like this is, just take a deep breath at any point. If you're feeling overwhelmed, take a deep breath and release and say Python is easy. Because I'm telling you, like it seems like it's a lot, but it really isn't. And it's just me talking real fast, trying to explain it all. This is super easy compared to any other programming language. Like we're doing all kinds of fancy port scanning and connecting and serving like that. This was all we had to do to create a server. It's easy. Python's easy. So hope this was helpful. Thank you very much to my Patreon patrons. Take it easy, folks.